right, so Mr. Coy is planning more storage sheds. So let's take a quick peek at these sheds that he's thinking about. We have shed E and shed F. Which shed is bigger, E or F? Well, shed E is bigger. How much bigger does it appear to be? Well, if I look at it, shed F looks like it will fit in there twice. So E is twice as big. It looks to be about twice as big as shed F. How about sheds G and H? Which one appears bigger? Well, G. About how much bigger is it than H? Well, again, it appears to be about twice as big. So, let's make a prediction. Actually, let's read our question, and then we're going to make a prediction. It says, Mr. Coy is planning more sheds. He wants to know how the areas of the sheds are related. How will the areas of sheds E and F change? How will the areas of shades G and H change? Use the graphic organizer to help you solve the problem. So let's make a prediction. How do you think shed E would have to change to make shed F? How do you think shed G would have to change to make shed H? I would like to predict that the change is going to be about half the area. Remember, we're still working with area. We're finding area. And if G is twice as big, and then we go down to H, I'm going to say that our area drops by half. Let's see if I'm right. It says, what do I need to find? Well, I need to find how the areas will change. So how will the areas change from E to F and G to H? That's what I need to find. What information am I given? Well, I know the length and the width of all the sheds. Right? Yes. And I can use that to find my area because I know that length times width equals area. So what is my plan? I'm going to use this table to record the area of all of the sheds so that then I can compare how they changed. So I am going to use the table. That's an H, promise. We are going to use the table. So let's do this thing. Shed E. What is the length of shed E? Remember, length is the long one, like going up and down. So the length is 5 feet. What's the width of shed E? That's 8 feet. Pardon me, I have a tickle going on in my throat today. How about shed F? Shed F is also 5 feet in length, but it's only 4 feet in width. So let's find the area of sheds E and F now that we have that information recorded. What is 5 times 8? Well, I can count that out on my fingers if I need to. 5, 10, 15, 20, 25, 30, 35, 40. 5 times 8 is 40. And then my unit of measure, foot times foot, is square feet. Okay? How about this one? What's 5 times 4? Well, I know that 5 times 4 is 20 square feet, because feet times feet. So, look at how that changed. We went from 40 feet to 20 feet in area. 40 to 20. What's the relationship between those two numbers? Well, 20 is half of 40. Let's see what happens with G and H. What is the length of shed G? Remember, length is the long side. 10 feet. How about H? Pardon me. H is also 10 feet. How about width for shed G? Shed G is 8 feet. And shed H is 4 feet. What's 10 times 8? Pardon me. 10 times 8 is 80. And it's still square feet. How about 10 times 4? 10 times 4 is 40 square feet of area. So the area of shed G is 80 square feet. The area of shed H is 40 square feet. What do we know? What's the pattern between 80 and 40 square feet? 40 is half of 80. So what is our pattern? Our pattern is it goes down by half. The pattern is that if the lengths are the same and the widths are halved, then the areas will change by half. It goes down by half or decreases by half. So our pattern, the area decreases by half when the length are the same and the widths are halved. Okay? So the area decreases by half when the lengths are the same and the widths are halved. How did your table help us find the pattern? Well, it helped us know what the multiplication was that we needed to do to find the area. It also helped us to be able to see these two numbers side by side and know that 20 is half of 40, or that 40 is half of 80. So it helped me organize my numbers. So here's a question for you. What if both lengths and widths of the sheds are doubled? How would the area change? Let's try it out with this one. All right, let's try it out with shed E. If the length is doubled, that means it's 5 times 2. If it's doubled, it's times 2. If it's halved, it's divided by 2. So 5 times 2 is 10. Right? So 10 feet. And then I also need to double the width because it says the lengths and the widths are doubled. So what's 8 feet times 2? Well, 8 times 2 is 16. Right? So now I need to find 10 times 16. I love multiplying by 10 because it's probably one of the easiest things. All I have to do is add a 0 to this number. So 10 feet times 16 feet is 160 square feet. How does that compare to 40 square feet? Well, it's definitely bigger, but how much bigger? Well, let's figure it out. How many times does 4 go into 16? I'm just taking the zeros off to make it a little easier. So 4 times what equals 16? 4, 8, 12, 16. 4 times 4 equals 16. So if I add the 0 back on, 40 goes into 160 4 times. So it is 4 times as big. Another way I could write that, 4 times as big as this one. So if I double the length and I double the width, it becomes 4 times larger. Just by doubling the length and doubling the width, we get 4 times larger, which makes sense because our pattern here, if we halved it, it becomes half as big. On the first one though, whenever we doubled our length, we got double the area. So if we're doubling the length or doubling the width and doubling the length, then it would make sense for it to go up 4 times instead of just 2, because we doubled something else. So 4 times. A very interesting pattern. All right, on the next page, you will have one more video lesson for the share and show, and then you will have some problem solving to do on your own.